welcome to tonight's TI Technology webinar hosted by Texas Instruments, Australia. We are really excited to bring you introducing the binomial and normal distribution, probability distributions in fact, with two very experienced mathematics teachers and TI Technology users, Melissa Horrigan and Craig Brown. My name is John Bayman, and I am your house host for this event. I teach mathematics to Year 7 to 12 students at O'Loughlin Catholic College here in Darwin, where I use TI technology to help students make stronger connections in their understanding of mathematics. And I am very excited, I'm sorry for messing you around, Melissa, to introduce our first panelist. Good evening, Melissa.
Good evening, John. Good evening, Craig.
Good evening, Melissa.
Melissa certainly walks the talk when it comes to TI technology, having followed the development from using the TI-82, for those who can remember that, through today's TI-84CE and currently uses the TI-Nspire, along with the Navigator system. Melissa, do you have the new TI-Nspire?
I don't yet. I'm actually still using the current TI-Nspire, but I look forward to hopefully getting one shortly. Here in Queensland, we are using the non-CAS version, but I'm looking forward to seeing the new one that can convert between CAS and non-CAS.
Yeah, and there's some nice webinars already around by TI about the differences and the additions that are on those calculators.
I shall have to go watch them.
Wait till you get your calculator first. I'll say, so this gives her a deeper knowledge of the use of technology and first-hand experience, as you can hear there, applying this and maximising our students' learning. So, Melissa, thank you for joining us this evening.
Happy to be here. Thanks, John.
Our second panelist for this evening is Mr. Craig Brown. Good evening, Craig.
Good day, John. Good evening, everyone.
Craig is an experienced teacher of mathematics with deep knowledge of using TI technology. Craig knows how to apply this in his classroom context, where he has experienced firsthand the benefits of his teaching and the understanding of his students of using technology. So, Craig, thank you for joining us and sharing your knowledge with us.
No worries, John. I'm just sharing my screen now with a bit of luck. Can you see what I've got?
We can see that crystal clear. Thank you very much, Craig. It's all yours.
Fantastic. Time to kick off. Okay, ladies and gentlemen, my part of this evening will be to show you how we can use some of the functionality of the TI technology to help us teach some of the important concepts involved with the binomial probability distribution. And so when it's all said and done, largely what I've got to show you tonight is quite a useful teaching tool. So the first thing we need to do is set up what we would perhaps call a typical binomial problem. So I'll click onto the next page here and scroll up. So what I've got in front of us here is what you would probably say a typical binomial probability distribution problem. We have a clay target shooter known to have a probability of success of hitting a target of 0.5. There are 10 stations where he or she has to shoot from. There's an assumption that the probability of hitting a target remains the same from trial to trial, and that the results from trial to trial are independent of one another. So I think we could all agree that it would be a typical binomial probability question. Perhaps the first thing we could look at doing when we come to teaching this would be to consider generating some random numbers that follow the binomial probability distribution. And so what I've got here is a maths box showing the calculation of those numbers. So it's called rand bin, and I'll show you how we can find that in a second. But probably first we have to understand, if you like, the syntax. The 10 there is the number of trials. So far as this question is concerned, it's 10. And the second number there is P, the probability of success. And so as you can see, I've generated a random number and it's 3. So in other words, our first simulation is that the fact that the shooter has hit 3 targets. The maths box here is highlighted, so if I just press enter now, I've now, if you like, the next lot of 10 shots that the clay targets had a go at, they've hit 6 targets this time. If I keep pressing enter, we can keep simulating how many shots how many targets has been hit successfully out of the 10. So for a start, I think this would be a useful thing for the whole class, because naturally enough, the whole class would in fact be getting different results. And what I've done in the past is, once that's been done, you gather the class in groups. Okay, how many, those people have got 4, you group together, those people have got 5, group together, and so you can start looking as to what the probability distribution might look like. Now, for those people who are wondering where you might want to find this random number generator, I've got a second page, or second document open here. If we press Menu, and then Probability, and then down to Random, you'll see there's a number of random number generators here, one of which is a binomial. And so I've actually got this demonstrated on a calculator page at the moment, but there you go, so it's rand bin. So if I type in 10, 0.5, close my brackets and press enter, there we have it, there's another result. And if I keep on pressing enter, there's the calculator page version of what I've just been doing. And so I'll just click back now to our document for this evening. And so that would be perhaps the first thing we could do, but we can do by far more exciting things, which I've sort of got a little prompt here, and that's perhaps demonstrated on the next page. So I'll click onto page 1.3. So what I've got here is, in fact, and I'll just click back to, for a start, 1 to make this a bit more sense. I've actually got, if you like, a sample size of 1, a bit like what we were just doing over on this page here. All right, and so a particular 10 trials, there have been 5 successes. So that's just one example. So now if I just reset that and go for another one, there's out of another 10 trials, there's been 6 successes, or if you like, 6 targets hit. But what I've got the ability to here to do is actually increase the sample size. So let's do it twice instead. And so now, that's a bit like saying there's 2 students. Now they've actually run the trial. One student has got 5 successes when they've run it on their calculator, and another student's actually got 7. So where this could be quite a useful exercise is if we then perhaps increase the sample size to maybe a typical class size. And if I have a class size of maybe 20, I've got a probability of success of 0.7 there, so what I probably should do is, for a start, have something along the lines of 0.5, like I had initially over here. And so you can see now we've got, if you're a sample following the binomial probability distribution. And so we've actually got, if you like, 3 instances out of the 20 where you've got 3 successes. So it's a bit like saying out of our class of 20, 3 of them got 3 successes, 4 of them have got 4. So you can look at the, get the class now, look at the relative frequencies to get an approximation of the probabilities. Now, part of what we've got to actually teach when we're teaching the binomial probability distribution is the effect of altering P. And you've already seen me do that already, but I'll do it again. If we perhaps change P to a higher probability of success, we can start talking to the students actually what that's doing to the number of successes. And you'd probably be having conversations, well, does that sort of make sense or not? And of course, if we in fact decrease the value of P, we have a look at the distribution again. We can do the same thing by increasing the number of trials as well. And so if we increase the number of trials to maybe 20, so now we're basically, in terms of this clay target shooting example, instead of shooting at 10 targets, we're now shooting at 20. The only thing you'll notice down the bottom here, that this is still set at 10. So what we need to do is press Menu, Window Zoom, Zoom Settings, and maximum. Change that to maybe, I always go a little bit more than what we need, so maybe 25, and press OK so we can actually see the whole distribution. So that is the first thing we can start having a playing around with our class. But what we've also need to do then is start looking at, well, what about the theoretical calculations? And so what we've got here is the ability to compare our theoretical, if you like, calculations from our samples to what we get when we look at the actual binomial probability distribution. And so we've got the Binomial Pdf here. As you can see, this is actually calculating the probability of x equaling something. So in other words, for, and I'll go back over to here, we need to set our n, I'll go back to n being originally 10. So I'm just clicking that, and probability of success being 0.5. The theoretical calculation for 5 successes or 5 targets being hit out of 10 is 0.246. If you're wondering again where to find this on the calculator, if I go to here, I'll show you. So I'm back onto this calculator screen. But if you go to Menu and go to Probability and then Distributions, and then you'll notice down here we've got Binomial Pdf. If I actually go down a bit further, we've got Binomial Cdf, which I'll be using later on. And then afterwards, also inverse binomial functions as well, and I'll be using that shortly as well. And so if I choose Binomial Pdf, number of trials, 10, probability of success, 0.5, put in our x value, 5, press OK, and I get the result that I got before on the notes page. So if I click back over to here, this would be a good opportunity perhaps to talk about the rounding function. We have got the ability to use the round function. And so if we press the library button and then type in R for round and then scroll down, we'll find the function round on the calculator. We press enter. And this gives us the ability to be able to round to a certain number of decimal places. So what I'll do is if I now put (3) and press enter, that's actually rounding my result off to 3 decimal places. If I change it to 4 decimal places. However, I've got another neat way of showing you how to actually use the round function a little bit later on, so I'll come back to that. On the next page here, instead of just single calculations like this, I have got, in fact, the distribution being calculated. And so for our set value of n here, for n equals 10, probability of success being 0.5, the distribution is being calculated, and we have it being plotted. So this is where, again, we can talk to students the difference between the distribution from the theoretical point of view as to opposed our random samples over here. And so it's worthwhile, you know, and making that comparison. So if we go back over to here, and again, now that I've got my theoretical distribution calculated, if we go and vary, oops, I've got to go backwards a bit more, go and vary the value of P. You can see having an effect here, but now if what does it have on the what effect does that have on the theoretical distribution? Again, you can see how it's skewing the distribution, and so that's again something we have to. It's an important feature that we have to teach.
Craig.
This last. Oh, sorry, John. Were you going to say something?
Yeah, just a couple of the attendees tonight have just asked about this great document. They're saying how impressed they are with it and whether they could get access to it. Am I right in saying that you'll be sharing this on the on-demand page later on after this event?
Absolutely, mate. That it goes without saying.
Mate, you're like Santa Claus, but just a few months early.
Ho, ho, ho. Righto. Okay, now this last page, I've got this last page hidden. These are the results being generated for this page here. So if I actually set this back to a sample size of 1, like I had before, it started off, and if I go back to that last one, that, as you can see, that for one go of 10 shots, apparently there were 7 successes. So that's the role of that page. I just had it hidden at the end of the problem, so it was out of the road when it's all said and done. But that's the significance of that page. So when you get it, don't delete it because you need it for that for the graph that I showed you before. Now, moving right along, what I've got here is basically a calculations page when it's all said and done that just requires us to enter in N and P. So as you can see there, I've got N and P entered. And I press enter there, N and P is automatically, if you like, substituted into the Binomial Pdf function, and there's the probability calculated. Now, if I happen to change the value of N to 20 up here, you can see that the results through here on the notes page are automatically reflected. And that's the beauty, I think, about using a notes page compared to a calculator page. Any calculations that are related to one another, you make that one change for N in this case, and the results are automatically reflected through here. Now, I did say before that I've got a nice little trick to show you about the rounding function. So we can actually do the rounding off in one go, if you like. It's a clever use of sliders that I've seen some of our fellow presenters use before. So I'll show you how this is set up. What I'm going to do is in here with the Binomial Pdf calculation, I'm going to type in the word round on my calculator, on my software, but I showed you before where to find that in terms of the calculator is concerned. So I'm rounding to comma, and I'm going to insert a slider in a minute, and the slider is going to be called RD for round or something like that. And so I'm going to close that and press enter. And I'm going to do the same thing down here for the Binomial Cdf. As you can see, the CDF function of the calculator there, that's actually calculating the probability where x is between 4 and 10 in this case. So it adds those probabilities up and gives 0.586 blah, blah, blah. Now what I am going to do though is again type in round here and come over to here, go comma D for my rounding slider. And I'd probably, in the ideal world, probably I'll do it anyway, let's do it down here as well for the calculation of the standard deviation. So ROUND, and I'm going to go comma RD. That'll do. Now the last thing, and this is hopefully this impresses everyone in viewerland, I'm going to come up to the top here, insert a line, and I'm going to insert a slider. So I need to go. I go to menu. Wrong spot. Insert, and then down here to slider. So I'll click on that. Now the variable for this slider is called RD. I'll start off with a value of 1. -5 would be a bit of a silly number for the number of places to round off. So let's round, could possibly be no decimal places, up to maybe 6 decimal places. Step size, you'd be wanting to go up by 1 decimal place, so we'll change that to 1. And the other thing I would do is change it to the minimised version of a slider. If I press OK, the minimised version of the slider is the little arrows here, the little buttons, if you like. Now, at the moment, you can see that it's set to 1 decimal place. But now if I click onto 2 decimal places, oops, hang on, press Enter there, and I'll better go down here. I did press Enter down there. It's to 2 decimal places. Now I'll hit the 3 decimal places, 4 decimal places. You can see that everywhere I've actually inserted that slider to those decimal places, it's actually displaying the results. The other thing you might want to do, and I'll just demonstrate this on one particular one of these boxes, you can actually hide the input by formatting a maths box. So I'm going to highlight that maths box, and I'm going to go Control, Menu once it's highlighted. We go to maths box attributes, and I'm going to hide the input. In other words, hide what's been typed in. When I do that, just the result actually gets displayed. Now, some people might like that in terms of tidying up a page. Some people might prefer to actually have the functions there. That's sometimes a bit of a personal preference. But sometimes there is a need to actually tidy the pages up because they can get a bit cluttered. One last thing before I hand over.
Craig, just on that note, that slide you're on.
Oh, sorry, mate.
Just on that slide you're on, Viewerland like it from the comments that have come through on the live chat. There's some nice comments about adding a slider. Most people obviously have used sliders in the graphing screen, but there's some nice comments saying that they hadn't even thought about using it in a note screen. So thanks for showing us that. Big shout out to Sanjeev there as the first person I saw use it, and I thought it was a clever way of using the sliders, I must admit. Yeah, beautiful. So, the last page I've got, and some people are perhaps unaware of the fact that the last couple of versions of the software actually have the inverse binomial function now, where you're able to calculate either x, or in fact the number of trials, x being the number of successes or n being the number of trials. So I've got an example here where you might want to actually find the number of trials. Let's look how this works. Find the number of trials it would take when a binomial experiment has been conducted where the probability of success P is equal to 0.6 and the probability of at least 3 successes is more than 0.95. Right, so if we actually set the problem up, you can see here, the probability of x being at least 3 is bigger than 0.95. Now, the way this cumulative probability here, though, is not what we need to actually put into the calculator. It's the next line down. Probability of x being less than 3 has to be less than or equal to 0.05, which means that would be x being less than or equal to 2. Now, if we go down to the next line, here's the inverse binomial here. There's a couple of ways you can display the result. You can display it in matrix form. So as you can see here, if n is 7, then the cumulative probability of less than or equal to 2 is 0.09, but that doesn't actually fit that condition. But when n is 8, 0.049, blah, 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 does fit that condition. And so the answer is actually 8. If I go to this page here, like I said, like I showed before, and if I go to Menu, Probability, Distributions, and over here to Binomial, Inverse Binomial N. I want the one with the N because this N stands for the number of trials. This one above it is to calculate X. So I want that one there. So if I choose that, this is what you actually look for. So if I put in the cumulative probability that I had before, 0.05, probability of success was 0.6, the number of successes was 2.
Now you can see up this tick box here. If you tick that, you'll get the matrix form like I had before. So I'll show you what happens if you don't actually make that tick. If you press OK, it just gives you 8 as the answer. So some people might prefer that. I sort of I do like that as a discussion point in terms of the teaching for our students, though. It's actually quite good discussion point. But that probably brings, before I'm about to sign off, I've got the syntax for the inverse binomial there, but I've also shown you on the webinar where to find it as well. So that probably is time for me to sign off, John. I hope everyone got something out of that.
No, it's great. Thank you, Craig. There's some really nice comments that people have made about that. So as we were waiting for Melissa to take over the screen, I think the really nice thing, like you said, is that you give the visuals, but it also gives a nice discussion points for students and teachers to discuss. You know, like so much at times statistics can be dry, and this gives a real visual relevance. And like I said, that when you use the matrix, it really gives that nice boundary as well.
It does, yeah. I agree.
Great. Well, thank you, Craig. And Melissa, it's all yours. We can see your screen and hopefully we can hear your voice.
Excellent. Hopefully you can.
Wonderful. Thank you.
All right. Thank you, Craig. And so what we're moving on to, the other part of tonight's session is looking at the normal distribution. Again, we're looking at it from the point of view of teaching tools. So the normal distribution, it's a density function. And usually when we're teaching it, most textbooks, they provide the density function, which I've got on the screen there. There's a couple of different versions of it. Sometimes you see the x minus mu squared over standard deviation squared, etc. And from there, they basically then go straight into using the tables. So you've got to go to the index back or the appendices at the back of the textbook, and the students start looking up tables. And of course, they're all based on having a mean of 0 and a standard deviation of 1, which is your normal distribution, your standard normal distribution. The problem or the difficulty in that is that obviously real life data doesn't have a mean of 0 and a standard deviation of 1. So that takes you then in from a teaching point of view to looking at converting your data so that you then start working with Z-scores. Now, what I like about using the graphics calculators is that you actually don't have to calculate Z-scores at all, because we can use that density function, we can use the features of our calculator to be able to investigate any sort of real-life situation that we want to without having to read tables, which also means from an exam point of view, we don't have to photocopy lots of probability tables and attach them to the back of the exams and that sort of thing. And we can make it that it's a bit easier and quicker for the students to actually do it, which is what the calculators really need to be doing. They are a teaching tool. We need our students to see the real-life applications, that old problem of when am I ever going to use this? How many people do you know carry around the probability tables printed in their back pocket? Not that I'm saying I carry my graphics calculator in my back pocket, but I'd be more likely to than the printed tables. So what I want to look at tonight is two activities that I've got here that I've set up. And as with what Craig did, Craig said, I will share these to the website so that you are able to access them and use them as you please. They're very basic ones that I have set up. So what we're going to do, first of all, is use the TI-Nspire and introduce the students to the normal distribution and the types of things we can do with the calculator to do that. So I'll just go into my calculator. So what I've got here is a document set up which I've called Introducing the Normal Distribution. I've actually taken a couple of pages out which we're going to add into it now. So there's a table of data. I have copied that from a textbook, so it's not the best picture, but when you're looking at it on the screen, it should be a little bit easier to see. hopefully. So what they've been asked to do is investigate the distribution and decide, is it normally distributed? So what I've done here is I've put in prompts for what the students need to do. So the first thing they need to do is to enter that data into a list and spreadsheets page. So you could actually have the students, they don't need this whole document, they can just enter that data into a list and spreadsheets page, or you can give them the document. Now I've actually already entered it just to save time, so this is what I've prepared earlier. And so then what we need to do is to have a look at how does that plot, because we want to decide, does it fit a normal distribution curve? And we would have spoken to the students about it being a bell curve, perhaps shown them some diagrams, they may have looked in the textbook. So the first thing that a lot of people might look at doing is to actually add in a page here. So using Control and the document key to add in a page. The first one I'm going to look at is a data and statistics page. And so there's all our data points. So what I need to do is to put mass on my horizontal axis and put frequency on my vertical axis. And you'll see there, I just get the dots for where the frequency is. Doesn't look much like a normal curve, and normally we would be comparing or looking at a histogram to then decide if it does fit a normal curve. Now, if I just go back to my data set, when I go into, on my graph, when I go into menu, I can look at changing the plot type, but it doesn't let me do a histogram. Part of the reason why I wanted to show you this page is because what we actually need to do is on our data set, so I'm back in my list and spreadsheet, is I'm actually going to choose menu data, and then I'm going to go down to summary plot. When I do the summary plot, I need to make sure there are only two variables here that I've got, but mass and frequency are the two variables I'm working with. So my X list or my horizontal axis is mass, my summary list is frequency. I can choose to either display it on a split page. I prefer to actually add a new page in because that gives me a whole page to look at. So what I'm then going to do is hit OK, and it adds in a new page for me. So you'll notice this is now my page 1.3, and I can now see a bit better what my data appears like. It's not a perfect normal distribution. However, it does have a bit of the shape of it, skewed slightly. So what we need to do is then look at an analysis of it, so the actual mathematical analysis of our data. So the next page that I actually had in the original document, again gives instructions using a one variable stat, determine the population for the mean, the population mean and the population standard deviation. So what I'm asking them to do here, the one variable stats they could do back on their list and spreadsheets page, but I'm actually going to do it on a calculator page. So you insert a calculator page here, which I've actually inserted a calculator page. If not, you can do Control, Doc, and then choose Calculator. Go into my menu. Notice I've got a new menu here because I'm on a calculator page, and I am doing statistics. So I want a stat calc. I want one variable statistics. There is one list that I'm looking at. That list is mass. I still need to enter frequency, and I've got the heading there, frequency. I'm not doing categories, so I can leave that empty and then click on OK, and I get the summary information. Now, if I'd have done that on the lists and spreadsheets page, it just would have placed that into a couple of the columns. Now, what I want to use here, as I said before, the normal distribution is based around a mean of 0 and a standard deviation of 1. What I want to do is to actually use the mean and standard deviation of my data. So I'm going to define that information so that I can then graph it to see what the normal distribution should look like. So if I look at the top of my screen, my data has a mean of 6.71. So underneath my information, I'm going to write in define. I'm going to use M for mean equals 6.71 and hit enter. And it says it's done, so the calculator has saved in M the value 6.71. The other piece of information I need is my standard deviation, my population standard deviation, which is 2.23. So again, I'm going down to the bottom. I'm going to define, and I'm using S for standard deviation, and it was 2.73. Looking at that, sorry, it's 2.23. Better just change that and hit enter. Okay, so I've now defined those two pieces of information. To know what the normal distribution would look like for a mean of 6.71 and a standard deviation of 2.23, we need to graph it. Now, this is where I'm again coming back to the actual function, and I'm using that to graph my information. So I'm going to type in to my graphs page my distribution function. So I'm going to insert a graphs page, and I'm going to type in my function, which I have cheated and already typed in. In terms of the typing in, it's easy enough to do. Using control divide to get your fraction. You've then got your numerator of 1. I used S for standard deviation. It comes up bold because it is a variable. I have saved information in there. So I'll just take that out. So what I've got here is the function for standard deviation using, the function for normal distribution using S for standard deviation, using M for the mean. And when I hit enter, now, this doesn't look much like a normal distribution to me. A big teaching thing, and I constantly say this to my students, and they still don't always do it, is we need to remember when we draw a graph, if we were drawing this graph by hand, we would have to think about what do I need my axes to be. Because we're doing a normal distribution, we don't need our axes going into negative. So it's no use having the negative 10, etc. for the data I've got, because I've got a mean of 6.7 and a standard deviation of 2.23. So I need to go in and change my window, and I need to make sure that I allow for the values that I've got. So I might put in here my X minimum of, I'm going to put in 0. I'm going to put in a maximum of 10 to start off with. I'm going to make the scale just go up in 1s. That doesn't make too much difference. What I am graphing here, the normal distribution is, it's a value between 0 and less than a half, basically. So I'm going to have in here my Y minimum of 0. I'm going to have my Y maximum. I'll start off with it at 0.5, but I know that it will need to go smaller than that. And if I just have 0.1 as my scale. So I can actually see here now what my graph should look like as a normal distribution. And I can see as well, going up to 0.5 is too high, and also the graph is going off the side of the page. So I can easily go back in and just adjust those settings. I want to go past 10, I might go to 15, and I'll change my maximum to 0.3, and I might go 0.05 as my scales. And I now get my normal distribution. Now, what I want to be able to do is to compare the data that I had with my normal distribution. Well, at the moment, my data is back on page 1.3, and my normal distribution is up on page 1.8. That makes it a little bit difficult to compare. I'm going to look, there's a few different ways that we could do this. Okay, what I could do, it doesn't work quite so well, but what I could do is go into go into my entry in menu in terms of graph entry and put in a scatter plot of my data. The other thing that I've got to remember too is that the normal distribution, as I've already said, is a probability situation. Now, if I go back to my original data set, I've got the frequency there. So what I actually need to do is not have the frequency as my graph, but actually have the probability as my graph. So I've cheated a little bit here. I could put it on this page and put in probability. And then now it's already calculating because I've got it later in the document. So what I did do is to put in the probability and use frequency divided by 50 because the original question had 50 values in it. So now I've got the probability or the relative frequency. So again, I do a summary plot of that. So I go into menu, data, and choose summary plot. This time making sure that I choose, instead of frequency, I want to choose the probability. Now I hit cancel there. And what I get is now I've got a graph of the relative frequencies or the probabilities. I still don't have the information on the same page in terms of my graph for my normal distribution. It's over on page 1.9 or 1.8. I've got it there twice. So what I can do, though, is I can add in a graph. So when I go into Analyze, so Menu and then Analyze, I can put in Plot Function, and it comes up with a function here. Now, what I want it to plot is my normal distribution curve that I just put into F1. So all I actually need to type in here is F1 of X. Because I've already got F1 in there, when I hit enter, there's my normal distribution curve. So I can look at that and say, well, it's not too far off being a normal distribution. It is slightly skewed though. So that's the first activity that, or investigation as such, that I wanted to look at.
Melissa?
Now, yes.
Someone was asking, when you adjust the window, would Zoom Fit work better?
I don't like to use the Zoom Fit and the Zoom. I will sometimes use Zoom in and Zoom out. I like to do it more from a teaching point of view. The students like to use Zoom Fit, Zoom Stats, Zoom Data, those sorts of things. I actually prefer them and tell them they need to stop and think about what is the data. If we were to draw this by hand, we don't have a Zoom Fit. We actually have to stop and think, what points do I need to have? It's no use me drawing an x-axis that goes from -5 to +5 if my values are all larger than that. So while you can use it, I actually, from a teaching point of view, I choose not to when I'm in the classroom because I want the students to be able to think, what should it look like? So it's getting them to make that link between the data they've got, the graphs that they're wanting to produce, and the axes they have to have. So I tell my students that they've got to think about, well, if I'm drawing this by hand, I know that I'm going to have my mean of 6.7 or 7, my standard deviation, so I'm going either side of that. So what values will work best? They could then look at it.
That's a very valid point. That's great. Thank you.
Yeah. I I probably don't mind them after that doing something like a zoom fit or a zoom it out a little bit once they've initially come up with it and they can see what it should be. Whereas if they just hit zoom fit straight away, so they type it in and hit zoom fit, they don't necessarily understand the maths that's behind that process. So that's why I do it that way. Entirely up to you how you teach in your room. Obviously, that's something that I like to do. So the next thing that we usually look at when we're doing normal distribution is we need to look at the fact that what exactly does the normal distribution tell us. And so this is when we start looking at the fact that within one standard deviation above the mean and one standard deviation below the mean, we should have 68% of our values. And then 2 standard deviations either side, we should have 95.5% of all values in there. By the time you get out to your 3 standard deviations either side, you've got your 99.7% of all values. So you should be covering everything. So the other thing that I like to look at, and this brings in the second document that I've got here, is, again, how can we use the calculator to show this sort of information? So in my second document, which I'll also make available, I've put in there, and I've taken this question straight from a textbook. So the following page contains the exam marks obtained by 80 students in a maths test. So all I've done is enter them in, the list of 80, I typed them all in, okay? And we're asked a few questions. So using the data, you need to find the mean and the standard deviation. Well, in doing that, it's the same as I did just before. I could actually choose to put a calculator page in. I could actually just go into statistics, stat calcs, one variable statistics. It's one list, okay? In this case, I called the list, oh dear, what did I call it? Exam. So click on my down arrow, exam marks. There is no frequency list this time, so I'm leaving that as a 1. I don't have category lists. First result column is where can it start to put the information in. So I've only got data in column A. The calculator chooses to leave a blank column. So when I click OK, B is blank, and then I can go across and I can see my mean is 75, and I go down, and my standard deviation is 9.89. So I've been able to answer the first question. That says plot the frequency histogram. Well, again, what I am able to do here is in menu, data, summary plot. XList is the exam marks. I'm not doing a split page. So I'm going to go, okay, that's the results that the students got. So I've now done my frequency histogram. Set compare the histogram to a bell curve. So because we've already gone through and taught them about entering information, what they're able to do, because we've got the standard deviation and the mean of 75, our standard deviation of 9.89, what I'm able to do is add in my graph page. Again, I have prepared earlier. I've entered the function. I need to make sure I save what S and M are, so I haven't done that yet. I did do it earlier, but making sure that I've got the right information. So I'm actually going to add in a calculator page, or I could actually put in here, back on my list and spreadsheets page, I could put in S in here. No, it didn't like that one. I won't do that. I'll do what I was going to do initially. I'm going to add in either a calculator page or a notes page. I'll just do a calculator page. I'm going to define my mean was 75.04. I'm going to define my standard deviation was 9.89 from memory. I've now defined those. I go forward. I just want to turn on my plot, so I hit enter. Same situation I had before. Because it is a basic graph, it's trying to plot between -10 and 10. Well, I've got a mean of 75, so I need to go up around the 75. So I'm going to use my window. Now, I'm going to cheat. I go zoom fit. It started to get my information, but notice there, even going zoom fit in this one, it hasn't given me everything. It's given me only the first part of it. So I am going to need to zoom out a bit more, putting my centre to the side. Now, the other issue is because I'm zooming out, notice my y-axis there has become ridiculously zoomed. So I will actually go to the Windows and Window settings. So I'm going to go from 0. I'll just go to 100. I know we won't see all of it, but I do know we are also short on time. Scale of 10. My Y minimum is going to be 0. I'm going to do 0.4, going up 0.1, and let's see. Minimums must be smaller than maximums. What do I do? My minimum is smaller than my maximum. Oh, no, it's not. Yes, it is.
As I say, looks fine to me.
Yeah, that's what I was thinking. We'll go -1. Oh, there we go. Just doesn't like 0. Let me grab. It's been non-cooperative tonight. I think that's technology all through tonight.
But the nice thing is with technology, I think that I explain to my students that these things could happen to them, whether they type a wrong number in or whether they don't. And it's how they deal with that and how they troubleshoot. And I think that the lessons that they can actually get, obviously in an exam situation, you don't want that to happen, but there's a lot of life lessons they can learn from this. So do not worry. You're doing us a great experience here.
Okay, there we go. So now we've got our normal distribution there. Now, what I wanted to show, because I know we've gone over time because of our technology and I don't want to keep everybody, but the other thing I wanted to show that I was talking about before is it says compare the histogram to a bell curve. I've got the bell curve on one page. I've got the histogram on another. So we saw before what I can do. It also says calculate the percentage of students that scored between 65 and 85. Now, what you can do with this that's a good teaching tool is, and the students would absolutely hate it, but go through and get them to look at the raw data and find the percentage. But as well as that, what we can do, I'm just going to quickly put on here, menu, analyze, put in the plot function, and it was F1 of X, so we can see up. I forgot to do my probabilities here. I've only got exam marks.
Melissa?
Yes.
The other thing that we noticed as well with that window, I think the reason was that there was an asymptote at 0, and that's why it wasn't liking it. So if we just moved obviously slightly to the left, it would have been fine.
Oh, of course. Thank you. Because I've got exam marks on here, my function, it is actually on here. I would have to zoom right down. So what we need to change with that, this needs to be the probability here, which is a bit harder to do with the, because we've got raw data, we need to tabulate it to frequency. But what we can do here, and this is what I really like to do, and again, move away from the students having to do lots of Z-score calculations and go in and look at reading tables, is on the graph page, when we've entered in our data, we've got our mean, our standard deviation, what we are able to do in our analysed graph is explain to the students that when we're talking about the probability or the percentages such of students, we're looking at the area under the curve. So what we can do here is we go into integral, and for lower boundary, well, I wanted to know 65 was the value between the students between 65 and 85. So for lower boundary, I put in 65. For upper boundary, I'm putting in 85. And I've got 68.8% of my students if it was the normal curve. Now, it's pretty close to being a normal curve. So approximately 68% of my students got, or percent of those students got between 65 and 85. So that is that one standard deviation either side, which we saw before. So something that I really like with this is instead of having the students constantly go to tables and everything, is they can actually use the area under the curve. So by teaching them that the percentages are the area under the curve, because the area under the whole curve is equal to 1, which is 100%, we can have students investigate real-life situations without having to just use the tables in the appendix part of the textbook, and it's getting them to see the real-life applications, make that connection between the theory we teach them and actual real situations. So, and that was the last thing in my PowerPoint in terms of using the TI-Nspire for that area under a curve. And I know I've done it with a class. I had 12 Maths B here in Queensland last year, and we do the Z scores, and I taught them all how to use the tables in the back of the book, knowing that they'd be given the tables in the exam, but I also taught my students how to use their calculator for it. And at that stage, we weren't having calculator and non-calculator exams, but we can certainly set them up. In a calculator exam situation, which we're going to here in Queensland in methods, why not use the technology? We've got it. As I said, I'm using a CX, I'm using a non-CAS calculator here for everything I've done tonight. We're able to do in exam situations here in Queensland, and we don't have to have the students looking through page upon page of tables, etc. So that's the two things that I wanted to look at tonight in terms of introducing the normal distributions of students. I really like using the function. It's actually something I've only done for the last few years. I've always, up until about 4 years ago, just taught with the textbook in terms of the tables in the back of the textbook, and not had students entering it in as a function. But if they enter it in with the general, and they could even look at inserting sliders and that sort of thing as well. So the same as Craig did before, we could insert sliders if we hadn't saved the S value. We can put all that in, and we can look at all different normal distributions and that sort of thing, which means the students can investigate where these can be used in real life. John, that's the end of my section. So I'm going to stop sharing my screen.
Well, what a lovely way to finish as well. Thank you, Melissa. And like you said, I think that that practical visual example of the mathematics that they've learnt really brings it to life. And I think that from the comments that people have said tonight, both the things that you showed us and what Craig showed us, is things that people are going to take into their classroom over the next couple of weeks, if not months, when they're especially revising for their exams. So thank you very much.
Not a problem. Happy to have done it.
Okay, so we're going to begin wrapping things up. If you do have any last-minute questions, please try and get those asked. Craig and Melissa are still checking the chat windows, so I know that they will endeavour to answer them or equally add them to the future planning of webinars. And obviously, we had a few issues earlier with the audio, so please be kind to us. But we eventually sorted that out, so thank you for your patience. But when you do leave tonight, the webinar, there will be a brief survey which will automatically appear here in your browser. So your feedback does guide us as we plan for future online events. And believe us, we do listen to you, your feedback, and hope you do share your thoughts in a post-webinar survey. The all-important certificate of attendance will be emailed to you in the next 48 hours, along with links to the on-demand and YouTube versions of the recording, as well as any relevant documents that both Craig and Melissa have shown tonight. So please have a look through those again and equally share them with your friends and colleagues. After we leave tonight, if you do need some post-webinar follow-up, please feel free to phone or email TI Australia New Zealand. I know they'd love to hear from you. And sadly, that brings us to the end of tonight's webinar. Thank you so much, Melissa and Craig, for everything you said tonight.
Thank you.
Absolute pleasure.
Thank you. Thanks, Melissa. Thanks, Craig. I really appreciate it and learned some stuff from you tonight, and I know that our viewers have too, so thank you very much. And equally, thank you, everyone, for joining us this evening. We run these webinars for you, so I hope you find it useful whether you're watching live or on demand. So thank you very much, and good night.